In these next two videos, so 2.5 or set of videos, so 2.5 and 2.6, we're going to move on from the mechanics of graphing lines and finding the equations of lines to some information or some vocabulary around describing graphs, and specifically linear graphs, but these are also going to relate to other types of graphs that we'll be doing later in this course as well. So the first thing we're going to explore is the words relations and functions. Relations is anything where there is a relationship between a set of values. So what we're going to be talking about with graphing is the relationship between x and y values. You can show relationships in multiple different ways. You can show them as ordered pairs where the x is listed and the y is listed. You can show them using correspondence or mapping, where all of these are your x values and these are your y, and your x values are corresponding to a y value. So for example, if you took -3 as the x, it corresponds to 2 as a y. So everything can be written in correspondence or as ordered pairs. It can also be written using a table. So there's your point there, -3, 2. And you can also have a visual display of a graph, and there's your point, -3, 2. So a relationship is anything where you have a relationship between two data points, and so an x value and a y value. Then there's a very specific type of relation, which is called a function. A function is a type of relation where you only get one y value for every x value. So in other words, every input value of x will correspond to only one output value of y. So we're going to look at how to determine whether a relationship is a function or a relation. And we're going to start off by doing that at looking at ordered pairs, table of values, and corresponding. So when I'm looking to determine if something's a relation, or more specifically a function, I'm looking at the x values. If your x value is repeated, that means that there was more than one output for that input, or there was more than one y value for that x value. So this is a relationship, but it's not a functional one. And so we would call this a relation. Whereas down here, you can see that your x values are not repeated, even though every single one of them corresponds to the y value 4. Every x value has its own distinct y value. And so we would call this a function. To determine it from a table of values, you look again at the x values. Since it's never repeated, every x value only corresponds to one y value, so this would be a function. If you're looking at it in mapping, I'm looking at the arrows. Does the arrow from 0 go to more than one y value? And no. Even though some of the x values go to the same y value, every x value has its own distinct y value. So this would be a function. Whereas if you look at this corresponding, as soon as you look at this 3, the 3 maps to 5, and the 3 also maps to 7. So this input variable x has two different output variables of y. So this we would call a relation. So it's still a relationship, it's just not a functional one. Another way of looking at relationships or functions is from their equations or their rules. So what this is if I give you an equation like y equals 2x, this is a relationship between y and x, where you solve for y by putting in different values of x. So another way of saying that is that y depends on the value of x. So therefore, we also call y our dependent variable, and we call the x our independent variable, because it does not depend on the y value. This becomes more important kind of in like physics graphing, where you're looking at, okay, what's your controlled variable? So maybe time is my independent variable, and then price of a car would be my dependent variable. It depends upon the time the car has been left. But same thing stands for the definition of a function. For a function, you can only have one y value or one dependent variable for every independent variable you put in, so for every x value. So to determine whether an equation is representing a function or a relation, you put in different values for x. So you put in different independent variables. And if you can get more than one y value for that x value, then it's a relation but not a function. So for example, if I were to put in an x value of, let's say, 2, into this equation, I solve for y. I get -4 plus 7 is 3. I only get one possible y value when I put in an x value of 2. And in fact, it doesn't matter what I put in for x, like let's say -3. When I plug in that x value of -3, I get 6 plus 7, which is 13. I only get one y value for that x value. And no matter what I put in, that's the scenario. So this rule, or this equation, would represent a function. If we look at this next equation, y equals 2x, same thing. If I put in a value for x like -3, I get a y value of -6. I only get one y value. This rule is only going to give me one y value for every input of x that I put in. So this one would be a function as well. In fact, most rules or equations will represent functions unless there's something different about it. And so you'll notice these are both linear equations. The highest exponent is a 1. But if you notice this equation, and we won't encounter this in this course, I just wanted to show you an example of something that would be a rule that doesn't define a function, is that there's this weird y squared. So when I put in my value of x, I have to ask myself what value of y, when squared, would give me an x value of 9. So I could put in a 3. 3 squared is 9. So when x is 9, I get a y value of 3. But if I put a y value of -3 in, I would also get 9. And so I would get an x value of 9 could also relate to a y value of -3. So this is a relation. So my rule of thumb is generally if they're giving you an equation, it's going to be a function, which in 2.6 we're going to talk about function notation, and we can use it because really the only ones that don't translate into functions are something like this, where you have a squared y or a y to the 4, and then we'll determine that it's a relation instead. All right, next objective. Going further on of this identification of a function is that you can determine if something is a function by using ordered pairs or mapping or tables of values. You can also determine it from the rule. You can also determine if something's a function by its graph. So the rule for something to be a function is that every x value can only have one y value. So if we do something called a vertical test, that will check if an x value has more than one y value. So if we pick a random x value like this one here, I don't even know what this is, but let's say it's -2, and I drew a vertical line through -2. What I want you to notice is that it crosses your graph twice. So your x value would correspond to 2 y values. Therefore, this would not be a function. This would be a relation. So we would say that this fails the vertical line test. Whereas if you look at this graph here, again, we don't know what this graph is. This is actually an absolute value graph, okay? But just a random graph. All I want you to be able to do at this point is draw a vertical line and see if you pass through your graph more than once. In other words, does this x value correspond to more than one y value? Since it doesn't, this is a function. All right, so just looking at some different graphs, I want you to determine whether they are functions or not. So pause your video, get a guess, and then come back and we can see if you were right. So vertical line test, no matter where I draw this vertical line, I can't get a vertical line to pass through more than one point, so this is a function. Here, I can right away draw a vertical line there. I pass through more than one point, so this is a relation or not a function. Here you've got points. I know they're a little bit hard to see. You've got a point here and a point here and a point here, a point here and a point here. This point passes the vertical line test. This point passes the vertical line test, passes the vertical line test. But if I draw a vertical line here, I'm passing through 1, 2 points. So this fails the vertical line test. So it's not a function, but it is a relation. All right, go to your homework and practice determining whether something is a function or a relation, and then we'll come back and do domain and range.